Hi guys, today we're going to solve some more indices, and in this case, this is example 5 from your methods workbook. This is not too much of a hard example, it's just a little involved, and I think the biggest thing to help you in this is to remember that to solve indices we need an equal sign, which both of them have, and we need the same base, and unfortunately we don't have the same base. So at the moment, for the first equation there, 5 to the power of x minus y equals 625. 625 needs to change. The second thing is, on this side, we have 243, and we have a base of 3 here. So two of them have 3's, and the other one has a 243. That we're going to change that as well. So let's start with the 5 to the x minus y. And I'm going to think of 625 and think, how can I make it with a base of 5? So the fact that my base is 5 for 5 to the power of x minus y gives me the clue that I'm going to want a base of 5 as well for 625. And actually, 5 to the power of 4 is 625. So 5 times 5 times 5 times 5 equals 625. That means instead of 625, I can write 5 to the x minus y equals 5 to the power of 4. And now we have an equal sign. Whoops, not there. We have an equal sign and we have the same base. And with that, we're able to cross out the bases, as you know. We get x minus y equals 4. Now that's an equation we can use, but I'm just going to keep that there for the minute because I can't solve that. There's too many variables to solve. Let's go to the next part here. We've got 3 to the power of 2x and 3 to the power of y, and then we've got this 243. So I want to think about what I can do with 243 to make a base of 3. And actually that's 3 to the power of 5. So you can times by 3, 3 times 3 times 3 times 3 times 3, and you'll get 243. Notice that you probably already know up to 81, so you don't need to count all the way from power of 2. Now I can say 3 to the 2x times 3 to the y equals 3 to the power of 5. Here I have a multiplication, so I'm going to multiply those indices, which means I add them. 2x plus y equals 3 to the power of 5. So now we're in the same spot we were with the last one, where we have an equal sign and we have the same base. And as we know, we can cancel the bases when we have an equal sign and the same base, only with an equal sign and the same base. So that gives us 2x plus y equals 5. And from there, I now have two equations that I'm able to solve simultaneously. I might take those up on this side. So what I'm going to do, I'm going to add them. I'm going to say let's add equation 1 plus equation 2. So let's do that. Equation 1, let's just highlight that so we know where that is. Equation 1 is here. And equation 2, how about purple? There it is there. And I've got x minus y equals 4. I'm going to add that to 2x plus y equals 5. Let's do that. 4 plus 5 is 9. Negative y plus positive y is 0. So we cancel that out. We are eliminating the y's. And x plus 2x is 3x. So this 0 we don't need. What I'm left with is 3x equals 9. And you can probably see, if I divide by 3 on both sides, x equals 3. So we've solved for x. So that's nice. We've got x there, and that's part of what they're saying. Solve for x. They want y as well. And all you need to do is substitute x equals 3 into one of your equations, either equation 1 or equation 2. So I'm going to do equation 1 because it's a little easier. So let's choose the easier one. So when x equals 3, x minus y equals 4, and I'm going to substitute that x with a 3. So let's minus 3 on both sides. Negative y equals 1, y equals negative 1. So there's my value of y. So at this stage, you probably would think, oh, I've finished this. It's a lot of work already. I've done really well to get to that stage. However, let's see, we solved for x and y. Over here it says, hence evaluate this thing. So I'm just going to move over here. I'm going to write that there. So we've got 35 to the x over 7 to the negative 2y times 5 to the negative 3y. And evaluate means we're going to find an answer. So let's see. X equals 3, y equals negative 1. I'll pop it there so it's easy for us to substitute. Let's pop y in yellow here. You can see where we're going to put that. And I'll put x in blue. So let's pop those numbers in. 35 to the power of 3. It's a bit nasty. 7 to the power of negative 2 times negative 1 times 5 to the negative 3 times 1.